Hi, good morning everybody. So today we're going to talk about liquid pressure. Liquid pressure means to say it is a force coming from any water component or even air component. There are different factors to consider when we talk about liquid pressure, in which these components are the density of liquid, A, base area of vessel, then H means the height or the depth of liquid. These factors affect liquid pressure. Factors affecting the pressure in a liquid. The pressure in a liquid depends on the deeper the liquid, the higher the pressure. So that's mainly the depth of liquid. Next, the density of the liquid. How heavy or light, okay, does the liquid weight is. The more dense the liquid, the higher pressure at particular depth. The other one is pressure of the liquid does not depend shape of the container. See, for example, the fluid flow like this leaky cap. So we have to use 3 holes, no, based on horizontal line. The pressure increases with depth, so the speed of water leaking from the bottom hole is larger than that from the higher ones. So what have you observed in this portion? So in this case, on the upper part, as you can see, the higher the depth, the slow the speed of the water's parts. While the second hole, it slowly reaches at the middle portion of the hole. It's getting faster. But this is a moderate water's parts. Then the last one, once it reaches to the very end or to the bottom portion, which is hole 1, you've noticed that the spurts out of these water spurts, okay, it's getting faster. So what does it affect? No? It says that the speed of water leaking from the bottom hole is larger than that from the higher ones. So let's now explore further. What if, okay, goes with equal pressure at equal height? So what are we going to expect? We have the same or equal hole, no, with a vertical position. So as you've noticed, that pressure acts equally in all directions. And when you observe, when you remove, no, those things, okay, with those covered hole, therefore, that equal pressure might have an equal height. It's because we have the same height, okay, and we have to expect that the pressure of air, no, continue to push through as long as that the water continues to flow. So in this case, pressure in liquids, a connected liquid in hydrostatic equilibrium, when we talk about hydrostatic, water at rest with equal amount. No? It has the same height in all open region of the container. So just remember that it won't affect their shapes. Even though the other one is cylindrical shape and the other container is in cone shape. So the pressure is the same at all points on a horizontal line through connected liquid in hydrostatic equilibrium. So when we talk about hydrostatic equilibrium, the pressure is the same at all points, no matter what the shapes are. Okay? But they are literally visible in horizontal line, okay, that connect liquid in hydrostatic state of equilibrium. So what is pressure in liquid? When we talk about pressure in liquid, it is a liquid in a container exerts pressure because of its weight. Pressure in liquid acts in all directions, as you can see. So let's now forward with this one. So as you can see, let's go back to our previous sample of container. We have hole A, B, and C, in which at different height, okay, in horizontal line or position. So this one literally not in horizontal position, but this is in vertical position. So in hole A, water from A falls closer to bottle with less pressure. Okay? So the space in there, okay, before that letter A, that's already the air pressure. And remember, it also exerted gravity, no? In which gravity or the density of water itself. Then, in hole B, water from A falls closer to bottle with less pressure than reaches to B, that turns out to be moderate flow, okay, with a little bit faster pressure. So it's moderate pressure. And letter C, water from C falls farther from the bottle, more pressure. So with A, B, C. So letter C might have a pressure effect. So water from C falls farther from the bottle with more pressure exerted compared to A and B. So in this indicator, the higher the slower, okay, the average will be moderate speed, and letter C, okay, the lower the hole, okay, you also observe because of the greater pressure from air at the top. So letter C may contain, although there is a shorter height, but the speed is quite faster due to more pressure exerted from the top. So pressure is lowest towards the top of the bucket. Okay? So water leaking from the highest hole under low pressure. Pressure is highest at the bottom of the bucket, while the water spouts at the highest pressure from the lowest hole. So again, our indicator here is one of the greatest factor, no, that might affect the pressure of liquid is also the air pressure and the density of water, okay, when it comes to its height or how deep or how far it is. Now let us move to buoyant force. So buoyant force, okay, this is the buoyant force in which the weight of displaced fluid is being described. So this component of buoyant force might also determine as well with positive buoyancy, negative buoyancy, and neutrally buoyancy or neutrally buoyant. So buoyant force is equal to the weight of water which is being displaced. So what is our formula? The buoyant force is equals to the pressure fluid times the gravity and the volume of liquid, where V volume of submerged object. But since, okay, the volume of submerged object, it should be converted to the buoyant force, in which it contains mass and the density, the mass and the pressure of an object. So therefore, the formula would be expressed as buoyant force is equals to the mass and the gravity and the fluid pressure and the pressure of the object. So the buoyant force is literally directly proportional to the mass and the gravity of an object, okay, divided by the fluid pressure and the object pressure. So that is why in this case, no, the buoyant force can be expressed through the presence, no, of due to these principles which is connected to Archimedes principles. Okay, so now we understand why some objects sink, why some object float, and why some object fully or partially submerged. So there are reasons behind this. Okay, now we will continue to Archimedes principles.